So welcome you all in the space dynamics lecture number 5, and my name is Uyul Srivastav. I'm doing my master from IIT Kanpur, and today we will discuss the circular orbit. And just in the last class also we have discussed the circular orbit, but some part we have left out for the circular orbit, but mostly the part for the circular orbit we have already covered. So let's continue without wasting our time. And guys, I'm very sorry because I'm not uploading into videos from a long time. The reason is the busy schedule in the Kanpur, but I will try to upload video regularly in the week, so you can enjoy the videos and just we can have some good grip on the subject. So without wasting our time, let's start. So now, right, one topic: satellite. So guys, we are doing the circular orbit, so we'll do the satellite in a circular orbit. When we'll come to the elliptical orbit, we'll do the satellite again. So first you understand the figure, then after we'll proceed for the wordings. Let's suppose this is your Earth. This is your capital Mars, Earth. Okay. Around the Earth there is a circular orbit. You all know. Okay. Let's suppose in this circular orbit we have stabilized our satellite. Okay, so now this satellite will revolve around this circular orbit with some velocity, right, with some time period. It will have some this. So now let's understand the time period and velocity of this. Okay, so right, consider a satellite in the circular orbit. Now the orbital velocity, or you can say the circular velocity, the circular velocity around the Earth at centroidal distance. Let's suppose from here to here, this is your center R at centroidal distance. Let's suppose this is your R. So the velocity is given by, we know that B orbital is nothing but your put under Gm by R in all order, right? Gm by R. But we know that, see, this is your equation for the circular orbit. We already derived this, fine. But we can also conclude it on the surface of Earth. V naught is nothing but your Gm divided by Ra, because we all know this, right? Because the height is basically 0. Fine. So now, right, we all know this because the orbital velocity, everything we know this about the circular orbit. Now you write the time period. So see, I have told you already. So this satellite will revolve around this capital mass M in a circular orbit. But after revolving, when it will start from one point, it has to come with some velocity at the same point. That velocity is called the orbital velocity, and it will have some time period to complete one revolution. So write time period. Time period. Fine. Right. The time taken by a planet, or you can say satellite, in a completing one complete revolution, complete revolution is its time period. We denote as a T. Fine. We know that for circular orbit, okay, let me take this. For circular orbit, the time period TP is nothing but the distance traveled, 2 pi r. Suppose this r is or a is your distance, we can say, right, divided by the orbital velocity. So this is your 2 pi a divided by put under gm divided by a, of course, because our radius, let's say, okay, let me take this radius as a fine, this radius is a. So this AL will cancel out from up and down, so it will come like, so when you square this TP square, so 4 pi square A square divided by GM by A. When you are squaring, what we are doing is we are squaring this two, this one and this one, fine. So we are getting this. Now it will go upside. So the time period square for circular orbit is equal to 4 pi square A cube divided by GM. Everything is known to you because GM and everything I have already discussed. What is GM, what is A, what is TP, and all those things. So you have the formula for this. Fine. So what is our equation number? Let me check. It is EF. This is your equation number F. Now see, what is this A? Do not forget, this A is your radius of circular orbit. This is your RA plus H, you can say, right? I have already discussed this A. Fine. Now you write the energy relation in circular orbit. So this is your time period when the radius is given, the height is given, the GM is already given. So you can find the time period. That means, let's suppose this point is from here to it is starting and again it is coming here. So there is one complete revolution. So for completing one revolution, what is the time it is taking by the satellite, that is calculated by this equation. So this is only for the circular orbit. When we will do the elliptical orbit, we will see something different. Fine. Now write the energy relation. So write energy relation in circular orbit. So we know that the kinetic energy is nothing but your half m the velocity square. But velocity we are taking in circular orbit, that is your half m v naught square. Right? This v naught is nothing but your orbital velocity. Guys, please make your own notes. Whatever I am writing in the way of writing the things or indicating the things in every steps, please write your own notes like this only, because you will forget. So better to understand. So we know already this v naught, but when you write here orbital velocity, your mind will remind something different, or you will think something different. So please write. Fine, it's your choice. So now when you square this, 2m gm divided by a, fine. So that is equal to capital G small m capital M divided by 2a. This is your kinetic energy in a case of total energy, or you can say the annihilation. Fine. Let me take it here. Okay. Yeah, now it is fine. Similarly, find for the potential energy. Or no need to give this. Yeah. Find for the potential energy. Notice potential energy is nothing but your minus G capital M small m divided by the A. This A is nothing but your radius. Previously we are using the R, but now we are using the A. The reason is same. There is no reason any different kinds of using the rotation. This is your radius. Fine. Now you merge this. So the total mechanical energy, that is E, is equal to m into Et. I already told you the relation between the total mechanical energy and the orbital energy, right? So now this is your m into, this is your kinetic energy minus potential energy. So if you write this, yeah, fine. So half v naught square minus gm by a. We are writing this equation from here, this one and this one. Only thing is we have taken the m common. Fine. Similarly, we can also write small m is nothing but your gm divided by 2a or gm divided by a. So you will get the total energy, or you can say total mechanical energy, that E is nothing but your minus g capital M small m divided by 2a. This is your equation number Fg. Right? This is your total mechanical energy, right? Total mechanical energy. Fine. So you can see this energy is coming negative. So as I have told already, let me show you. orbit. Yeah. So we are studying the orbital circular orbit, orbital orbit, right? So in circular orbit, you can see where it is. Let me check. Yeah, it will be here. Energy relation. Guys, 1 second. Let me check for your better understanding. Yeah, it is here. See. So I have told you earlier, for circular orbit or elliptical orbit, it will be negative. See, it will be negative, and I have told you already this. Yeah, this one. The it is nothing but your total energy divided by the mass. So the same thing I have written over there. So it has to be negative. That is why the negative sign has come into the picture in the equation number G, which I have derived now. This one. So now write note. The total energy is negative. This is true for any bound system. Bound system means for circular or elliptic orbit, right? Bound system. If the potential no need to is, yeah, no need. Fine. Now you write there is one topic, geostationary satellite. Yeah, right. Geo stationary satellite. Guys, there are lots of types of satellite which are having the different work. One of them is geostationary. Let's understand what is this. So write some words. The Earth rotates about its own axis, already, once in 24 hours. Then suppose a satellite is stabilized in an orbit in the plane of equator and the height is such that the time taken, or you can say the time period of the satellite is 24 hours. Fine. And it moves in the same sense as the Earth. Of course, it matters. Fine. Now, the satellite will always be overhead a particular point on the equator as seen from the Earth surface. This satellite is called geostationary satellite. Geostationary satellite. Fine. One more line you can write. Such satellite is satellites are used for telecommunication, weather forecast, etc. So I have told you already, there are lots of types of satellite which is orbiting the Earth in a circular orbit, but one of them is geostationary satellite. So geostationary satellite revolves around the Earth, and it completes one cycle or one revolution in 24 hours. Fine. So now see. So we know that the time period is 24 hours. So the time period is given by 24 hours. Fine. Now let's find from Earth's surface, or you can see what is the radius from the centroidal distance from, let's suppose this is your Earth, this is your circular orbit. And there is somewhere, you can say your satellite. So from here to here, what is distance? This distance we need to find. Let's find this. So you know that actually it is revolving in a circular orbit. So you can use this equation. Here we have derived this equation. TP is equal to 2 Fine. So use this. So TP square is nothing but your 4 pi square a cube divided by gm. This a is nothing but your radius. We can say here a. Right. So right, TP is square into gm divided by 4 pi square to the whole power 1 by 3 is equal to a. Right. Now substitute the value. 24 hours means 24 into, change into second, 60 meter, 62 second, the whole square. Fine. This value I already given, 3.986 into 10 to the power 14. Okay. Then 4 into pi square, the whole power 1 by 3 is equal to a. So you will get the value after calculating. You will get the a is nothing but your around 42241 kilometer. Right. So from the center of the Earth, the geostationary satellite is stabilized at a distance of 42241 kilometer. Let's suppose if you want to find from the Earth surface, then what to subtract? The radius of Earth, definitely. So if we want to calculate the height, of course. If you want to calculate height of geostationary satellite above Earth's surface, or you can say from Earth's surface, above Earth's surface. And how to find? This A is nothing but your RE plus H, right? So इसलिए that is why the H is nothing but your A minus RE, and this RE is nothing but your 6400 kilometer. So if you subtract, you will get H is equal to 35841 kilometer. So that is why this geostationary satellite has been stabilized in an orbit from the Earth's surface at a distance of this. That is your height. Okay. So let me check if there is any question about this. So okay, no question. Fine. So 26. Okay. So now it is completed, the circular orbit, whatever I have taught you. The 2 marks question and 1 mark question will be definitely from this till now. Mostly 2 marks question, because it's very easy question. It will come based on this equation, or else based on this equation, or else you have to find the time period and all those things. So basically you have to remember the formula, that when I will practice you the questions, so you will understand how to solve the problems. But we will do when once finish the space dynamics subject, and we'll take around 2 lectures to 3 lectures to complete these subjects. So let's finish now this orbital. And so next I'll teach you the Kepler's law for the elliptical orbit, but I want to continue from next class. So please enjoy this lecture now and revise till here. And if you practice any PYQs for this topic, you have to practice, and you're welcome to practice all those things. If you have any doubt regarding this, so please let me know in the comment box. I will try to resolve, and we'll do from next class the Kepler's law, that is for elliptical orbit. So whatever we have done till now for the circular orbit, the similarly we'll do for the elliptical orbit, and we'll not worried about the hyperbolic or parabolic orbits. So enjoy the video, and I will upload the videos regularly now. Make sure you revise the videos, and please make your short notes also. In short notes you have to write the formulas and in concept which is very important related to the formulas or the topics. So please enjoy your life, and we have time because it's a mid-March or end of March, you can say. So till now I have already 9 months, so I'll wrap up all the syllabus within this 9 months, and I'll provide all the contacts. Don't worry, please follow this YouTube channel, and please share with your friends or with your colleagues, whoever is having get aerospace chance to give the exam in 2026. So best of luck all guys. Thank you so much for waiting patience and stay with me. I will crack the gate 2026. Thank you so much.